Welcome to Campus Chat, a look at the people, the opportunities, programs, and happenings at Western Nevada College. Campus Chat is made possible by the Western Nevada College Foundation.
Hello and welcome to Campus Chat. My name is Helene Jesse, and this is the show about the people and programs of Western Nevada College. And we are in one of my favorite places on campus, the Jack C. Observatory. I'm here with Professor Robert Collier, who is the director of the observatory and WNC's professor of physics and astronomy. Welcome, Robert.
Thank you. Good to be here.
Yeah, thank you. We were talking the other day about how the very first campus chat was me and Robert in some conference room somewhere. We had yeah, exactly. I remember that. That's exactly right. So we always love coming up now to the observatory. The past couple of shows on Campus Chat, we've been talking about the stewardship of the Earth. How can we as human beings take better care of the Earth? Well, we're going to take a different twist on that today, and this is kind of a theory I really haven't considered before, is that maybe we can take better care of the Earth by going out into space, which I found that
That's
very
absolutely
interesting.
true.
Yeah, we'll talk about that.
Yeah, well, these days, Helene, we have high-altitude satellites that literally take the temperature of the Earth, and we can measure the radiations coming off the Earth. And of course, you know, with the onset of global warming that's really in the news and really in science today, we can actually measure things out in space that are really important to know about the Earth and what's going on and the conditions it's in.
Right.
Now, so yeah, we're even in space, even from the aspect of space, we can look and check out the Earth and see how things are going here.
Yeah, that's great. I think because there is some belief in some circles that global warming is a myth, and you know who you are. It's not true. I mean, it's just absurd.
99.9% of active scientists in the country right now, in fact the world, have agreed that we have a problem with man-made global warming. So, I mean, there's really no issue at all about that.
Right. At the Jack C. Davis Observatory, I don't think people know, Western Nevada is just truly blessed to have this fabulous facility with its ultra-sophisticated telescopes. In the second segment of the show, Robert's going to be showing us pictures of deep space, these beautiful objects, pictures that were taken with cameras and telescopes right here at the observatory. But I want to just read one thing that Sandy gave to me. It's a quote by Stephen Hawking, who, of course, is
the famous cosmologist, astrophysicist at Cambridge University in England.
Right. Very just
He also sits the Lucretian chair of mathematics, with the same chair that Isaac Newton sat when he was living. So he's quite a dude.
He's quite a dude. That's right. He's quite a dude. But this is what Stephen Hawking said in an interview with the Daily Telegraph in 2001. He said, "I don't think the human race will survive the next 1,000 years unless we spread into space. There are too many accidents that can befall life on a single planet. But I'm an optimist. We will reach out to the stars." So I thought that was an interesting quote. Let's just quickly talk about the 5th anniversary of the Jack C. Davis Observatory. It's hard to believe.
May 15, 2003, we had our first light gala event here, and Buzz Aldrin was here as a fantastic outpouring of people here to open the observatory, and here we are 5 years later, still with a large outpouring. Just last Saturday night, we had a large number of people up here making observations. We had telescopes around town, by the way.
Yeah, that was neat. Had one out in Dayton.
We had one in Dayton. We had one down in the south end of town. In the middle of town, I was there in the middle of town, and we had a group at the north end of town, and people were wowing all over the place, seeing Saturn for the first time. Never even looked through a telescope. There were many that saw the heavens for the first time, and it was a wonderful thing.
That's neat.
And of course, a lot of this has brought on the potential for all this. I can't do it. I'm the only paid employee at the college here relative to the observatory. So this whole observatory runs on
volunteers.
Tremendous number of volunteers.
I was going to say that we've been open 5 years, but we would not be open if it wasn't for the Observatory Board of Governors, headed by Brian Guerin, I believe, is the current president, and the Western Nevada Astronomical Society, headed by Mike Thomas.
Yes.
I mean, there's Jack Davis, Walt Dillard, Gerald Bransvold, Red Sumner.
Exactly. We also are having high school students getting involved too. So, and many of the people in the education community are coming up here and doing and inputting. So, we really it's a whole host of people that's making this observatory the success it is.
That's great. I'm going to need 5 minutes because wait till you hear this question, Dave. Why do you think we need to explore space?
Why do you think we need to explore space? Well, Elaine, in order to satisfy the desires of man, the inward desire of man to know and to seek out. We human beings are very unique in the scheme of things. We desire two things that drives us to try to get to the unknown, and that is beauty and truth. Those two things alone drives human beings in their mind and intellectual pursuits. It turns out that space is a laboratory. It is a tremendous laboratory. People think out in space. Guess what? We are in space. This Earth is in space. We are in space. The only thing that separates from raw space, the realities of real space, is this thin veneer called an atmosphere. And once you get above that atmosphere, 50 kilometers or so above where we're standing right now, you're in the wilds of space. There it is. And so I suppose that when the astronauts went to the moon and took the first picture of the Earth from the moon, and we saw what has been referred to now as the pale blue dot, with all the emptiness of space around it, the black encircling around the Earth, that gives us pause to think. We are small in the scheme of things, but yet we are alive. We are thinking. We've been blessed with a tremendous amount of intellect, and we're just beginning to open our eyes. And with our science and our instrumentation, we're now able to go out and to actually probe and investigate things. So it is a laboratory, and that's where we want to go.
Yeah, I don't think anyone can actually, if you lay flat on your back at night and look up into the sky and just look at all the stars, you just can't help but get a sense of wonder and awe about the universe. And for me, it does stimulate some pretty deep questions about, why are we here?
And Helene, we're fortunate that we can do that. Now, in many cities and places in the country, we can't just lay on our back and look up and see the stars because we can't see it because of all the light pollution.
Right.
And, Carson City, the supervisors in Carson City have passed an ordinance now in which we're going to try to attempt to limit and abate light pollution, because if we don't, no one will be able to do that. Right. And it is a wonderful natural resource that everyone should be a part of and be able to observe.
It is. We just built a light wall. I say we, the Foundation, the Astronomical Society, Gene Martin's construction class, and the volunteers built a light wall outside the observatory, and that's really helped the viewing, hasn't it?
Tremendous. It's the difference between night and day, basically. It really has
served its purpose then.
Exactly.
Well, we want to really get right to the pictures that have been taken up here at the observatory, and I'm sure it's a complicated process, wasn't it?
It's not a simple process. You see, the way it works, basically, just real quickly, is our telescopes are directed towards some celestial object, and we have CCD cameras that observe that. And the camera's black and white, so in order to see the object in true color, we have to take green images, blue images, and red images, and commingle those images together. And then we have to subtract out various kinds of noise, optical noise and electronic noise. And when all that's done, then we can begin to filter out. It's a raw image that still needs work done, but it's a pretty nice image.
That's great. Well, stay with us. We'll be right back with some fabulous pictures of the universe taken from cameras at the Jack C. Davis Observatory. We'll be right back. Welcome back to Campus Chat. This is Helene Jesse with Professor Robert Collier. We're inside the Jack C. Davis Observatory, and we're looking at celestial wonders. And no, Dave, that is not a new kind of tea. This is celestial wonders. Okay, Professor Collier, take it away.
Okay, well, thanks again for giving me the opportunity to show some things that's being done here at the observatory. Of course, this is the moon. Everybody's seen the moon, but this is a very nice image of the moon taken with our 10-inch telescope here. It's a Takahashi BRC 250. You know, the moon's 239,000 miles away. It's the third largest moon in the solar system. So it's kind of important to us. It gives us stability, and so there's the moon.
Where did the astronauts land?
Well, they landed several places along the equatorial plane. You can't see it here, but basically, right in here was the first landing. That's, of course, at the Sea of Tranquility. Okay. Now, this, of course, is a beautiful object called the Dumbbell Nebula. It is a star that actually exploded and is forming a white dwarf. This is called an irregular planetary nebula. It has nothing to do with planets. It's an exploding star. But primarily, this is gas, all kinds of material out here. The red portions of it is called hydrogen, produced by hydrogen light, and the green is produced by oxygen. And it's a very, very hot star, white dwarf in the center, about 85,000 Kelvin. It's extremely hot, one of the hottest stars that we know of. And it's ionizing this beautiful array, thin, tenuous gases around it.
Beautiful.
About 1,300 light years from here.
Jeez, that's beautiful.
This, of course, is Bode's galaxy. M81 is called. And the M number stands for Charles Messier, back in the 17th and 18th century, was a very great astronomer who actually began to see these objects, these beautiful objects, for the first time with a very small telescope, by the way. But many objects, about 109, 110 of them now, are called Messier objects. And so we put M in front of the number. So this is called M81. This is a beautiful spiral galaxy. It has an active galactic center. It's a very large galactic center, very hot. And you can see the dust lanes and the spiral arms of it. And this is about 12 million light years in space. This was taken by our Takahashi 10-inch telescope.
12 million light years?
12 million light years. One light year. A light year is not a unit of time. It's a unit of distance.
Right.
And it's a distance that light can travel in 1 year, which is approximately 6 trillion miles. So 12 million trillion miles from here.
Right. Okay? And our 10-inch Takahashi took that?
Yes.
Wow.
Yes. Pretty amazing.
That's pretty amazing.
And again, many of our volunteers came up here and learned how to do this, and they're doing a fantastic job.
It's beautiful.
Now, this is called the Crab Nebula, M1. This is an exploding star called a supernova, and it is 6,500 light years from here. This is the supernova that happened in 1054 and was first discovered by the Chinese and the Arabs, and was recorded in history at that time. So it's been documented when it was first seen.
Right, this is the Crab Nebula.
Yes,
yeah,
people could see this. People could see this during the day. It's so bright. It's still expanding, and it's expanding at enormous speeds. About 1,500 kilometers per second is the gas is expanding. It's been doing that for a long, long time. Now, the very interesting thing about this, right in the first, more or less in the center of this Crab Nebula, is a diminished star in which all this material came from. And it's a remnant. It's called a supernova remnant. And it is a special kind of remnant. It's called a neutron star. And this neutron star rotates about 30 times a second and sends out a beam, a jet, something like a lighthouse, that would send out a beam, and we can detect that beam. And so you're talking about a very exotic kind of a star. It is extremely exotic, and this is one of the beauties of the sky, M1.
Amazing.
Now, another galaxy, spiral galaxy. This is called M74, and it's just a mere 30 million light years away. And look at the beauty of this galaxy. You can see the actual dust material that's in here. Spiral galaxies like this, and we live in a galaxy very similar to this. Our Milky Way galaxy is a spiral galaxy. This particular kind of a galaxy is a star maker. This dust and material that you see here and gases around here are making new stars all the time. And so this is the kind of dynamic galaxy that we live in. For instance, our galaxy, the Milky Way, the distance across it is about 100,000 light years across it. And we're something like 25 to 30,000 light years from the center of our galaxy.
Mm-hmm.
And so we actually are moving and rotating about the center of our galaxy, just like there's rotation here.
Why is this picture so much clearer than the Crab Nebula? And the Crab Nebula was a lot closer.
Basically because it has to do with the amount of time that you take for your exposure.
Okay.
That has something to do with it. And so the time it takes is 20, 30 minutes per setting. And you'll do many 20 or 30 minute exposures, and then you stack them, and then you subtract out noise and things like that.
Mm-hmm.
So it takes, each of these images takes a long, long time. So they're not easy to produce. But they're fabulous once you get them done.
Boy, that is fabulous.
Now this is what's called the whirlpool, and this is in black and white. In just a minute I'm going to show it to you in color. But there are ways, there's things that you can see in black and white that's not as obvious when they're in color. So both black and white images and color images are very important. And so this is called the Whirlpool Nebula. These are two interacting galaxies. This one is referred to as M51A, and a smaller one, M51B. And so these spiral galaxies are interacting. In other words, material is going from one into the other. So you might say 51A is feeding into 51B, and they're interacting with each other gravitationally speaking.
Now these white dots are those stars?
These are stars. Now these stars are, of course, much closer, by and large, than the galaxy itself. The galaxy is a big light producer, so it looks like it's closer.
Mm-hmm.
But these stars are in the foreground, not in the background. Okay.
Mm-hmm.
Now here's the same galaxy in color, and look at the interactions. Look at all the nebulosity around the edge of this.
The gases.
Yes, and look at all the well-defined lanes here where star formation takes place. And of course the galactic center, many of these galaxies, like our own for instance, have what we think is a black hole in the center, and there's a tremendous amount of radiations centered in this area. X-ray, gamma ray radiations at the very active center.
So, what's the possibility of life as we know it out there?
Wow, what a question. Well, of course, we live in a galaxy very similar to a spiral galaxy like this. The same kinds of materials that exist here are existing in this area of the galaxy. And so, the chances are, I suppose that the chances are great. But until we can actually detect one and know that, then I can't answer that question. But one day, sometime out there in the future, we'll be visiting places, probably much closer than this one, but places where there is similarities in our own galaxy. If we could just go out and investigate our own galaxy, that would be something.
Mm-hmm.
Now, this is called the classic sombrero. This galaxy is a spiral galaxy, but it's on edge, and it has this enormous nuclear bulge. And notice that the bulge is much different here than it was when you looked at it in a different direction. And you can see that you have these very edge effect, dark dust lanes. So you're looking at the edge of a different kind of spiral galaxy. This galaxy has a much larger nuclear bulge, nuclear center. And so the Sombrero Galaxy is redshifted tremendously. It's moving away from us with enormous speed. But nonetheless, it is a beautiful object, and of course this was discovered by Charles Messier in 104. 29 million light years from here.
My goodness. That's gorgeous.
Now this is a comet. This is a comet that we detected here at the observatory. We didn't discover it here, of course, but it was discovered in 1894. By a British astronomer named Holmes. But this is really interesting. Back in October of this past year, we took this image, and this is the coma, and this huge amount of gas, which is mostly a hydrogen envelope around it. What happened was, we were looking at this comet one day, and it wasn't very interesting. In fact, it was very hard to see. And then all of a sudden, it started blowing out. And this coma in November of last year, the diameter of it got to be larger than the sun. And so everybody started focusing in and trying to take images of this. It looks like it looks like an embryo, doesn't it? Doesn't it remind you of an embryo? And so basically you have the central, there's a very small solid body in the comet itself. It's mostly icy material. But when it gets closer to the sun, then it begins to interact with the sun. The sun creates jets around it, and it sublimates material, and it's thrown out in space and forms this huge big envelope. So this is a fascinating thing. It's outbound at this point, going away from the sun, about 2 AU out from the sun at this point.
Astronomical units?
Astronomical units, yeah. That's the distance between the sun and the Earth, about 93 million miles.
Okay, thank you.
Okay. Now, this is called the Needle, and it does look like a needle, doesn't it? It's called the Needle Galaxy, and the Needle is a fabulous edge-on galaxy, spiral-type galaxy, and again, another type galaxy which has a rather enlarged nuclear bulge, and 53 million light years out. This was taken by our largest telescope, the C400. It's a 16-inch Takahashi telescope.
Beautiful.
Now, this is something we're proud of, and this is called the Trifid Nebula. The Trifid is 3 globs of matter, 1, 2, and 3, coming together, interacting with each other, and these very dark, what's called Bok globs, which are dark amounts of matter that are the seed material for the next generation of stars. This is a nursery of stars. Now, inside here, almost every kind of star in different times of its evolution. Stars are born, they live, and they die.
What kind of dark matter are you talking about?
Dark matter.
What is that?
Well, it's material. It's actually atoms and molecules of material that's made from other stars that wound up in this particular part of the universe. This, of course, is the famous Horsehead. Again, the Horsehead Nebula. You can see the Horsehead shape. There's also star formation forming in here as well. Right at the very crown of its head is a huge big star cluster of potential stars forming. So this is what's called the Horsehead Nebula, and 1,500 light years from here.
Close.
Very close. Now, this is one of the most interesting things. It's a globular cluster, NGC 5257, and it was taken with our 16-inch Takahashi. And this is dying stars. There's several tens of thousands, hundreds of thousands of stars in this one central neighborhood that are all on their last legs. They're in their death throes. So these are among the oldest objects in the universe. Some go back as far as 12 billion years. Now this is a combination of 2 galaxies in the same image, M81 and M82. We saw M81 a while ago. And would you believe that it's 1,500 light years between this object and this object? This is an irregular galaxy. This is a spiral galaxy. And they're gravitationally, of course, interacting with each other. 12 million light years out. This is in the constellation Ursa Major. And this, of course, is in the Eagle Nebula. This is called, you've heard of the Pillars of Creation that was taken by Hubble. Of course, we can't compare with the Hubble telescope, but we can certainly see the pillars, not as close up as the Hubble does. But these are huge pillars of creation. When you see them up closer, they're towering, huge, massive amounts of gas and dust that are producing new stars. And the winds, there's so much stellar winds around here that it's like tornadoes going on constantly.
Are these on our website yet?
We're going to be putting them up on our website right away. Yes.
So WNC.edu.
Yes, we'd love to have people come and make comments and let us know what you think.
Great.
And of course, this is Spiral Nebula NGC 891. NGC stands for New General Catalog. It's a way we codify objects in space. This was taken by the 16-inch Takahashi as well. There you see the tremendous amount of dust along the edge.
Beautiful.
And of course, we're back to the moon. So this is just a few of the images. We have many more in store for you.
Oh, that's great. So why don't we take a quick break? We'll be right back with Campus Chat. Stay tuned. Welcome back to Campus Chat. We're at the Observatory. If you want to get a hold of Professor Collier, his phone number is 445-4412, or Collier, Collier, at WNC.edu. He's got a lot of great classes, and we're open every Saturday night at the Observatory, free.
Yes.
And I know you want to talk about this.
Yes, I just want the camera to go over and show the people that actually were involved in all the imaging I just showed you in the last segment. Of course, Dr. Jack Davis has been here for most of the time we've had the Observatory open, and also Walt Dillard, Brian Guerin, John Sousa, who is a high school student coming up here doing a lot of great work for us, Red Sumner, our professional amateur astronomer here on campus, and Mike Thomas, he's the president of WNAS. So without these guys, and also the support of Gerald Brandvold, the technical support, these things would not have been possible by any stretch of the imagination.
Right. It's just amazing. We talked about Buzz Aldrin. He came in 2001 and then in 2003 to help us open the observatory. We have 5 coins left. We have actually 9 coins left that we had minted at the U.S. branch mint, and Buzz Aldrin and Jack Davis have signed 5 of them.
Fabulous.
And so if you have $1 million or more, you could get one of those coins, because that's what they're going for. That's how much those coins are worth.
And we have plans for that money.
We have plans
for that money.
Lots of
great plans for this college.
Big science park.
Yes.
Anyway,
amen.
It's such a great time to come up to see the observatory, isn't it?
It's great to have you guys up here and seeing what's going on here. And this is just the beginning. There's going to be there's so much potential for research here. We've got special filters now. I'm just through one of my NASA grants, I bought a lot of really sophisticated filters and software. And so we're going to be able to just do more and more and more. So stay tuned. By the way, I do teach astronomy here. I'd like to make a plug for my astronomy classes, AST 109, planetary astronomy on campus this fall, stellar astronomy, AST 110. If you'd like to know how stars are created and formed and go through the life cycle, we'd love to have you do that as well. So that's AST 110. Of course, I teach many physics courses, general physics, and all that sort of thing. So be sure check things out and come up here and learn about these things. It's a wonderful, wonderful, exciting area of science.
It is. Come up Saturday night. Any Saturday night we'll be open. I'd like to thank you again, Robert. I'd like to thank all our viewers for watching this special segment of Campus Chat. We'll see you next month.
This has been Campus Chat, a monthly program from Western Nevada College. Campus Chat is made possible by the Western Nevada College Foundation.